All right, so here is a really good example of what your test is probably going to look like for this year. This one came from the same people that wrote your textbook, so they know a lot and they're very organized. So definitely spend some time looking at this guy. All right, so Daniel believes that people perform better in the barbell curl on average if they are encouraged by a coach. Remember, context is going to get you over the edge on points, so keep that context in mind. He recruited 29 subjects to participate in an experiment and randomly assigned them into two groups. Daniel gave one group verbal encouragement during the exercise and was quiet during the exercise for the other group. He recorded the total number of barbell curls each subject was able to complete before setting the bar down. Explain the purpose of random assignment. All right, random assignment. The purpose of random assignment is to create two groups of subjects that are roughly equivalent in their ability to do barbell curls at the beginning of the experiment. All right, this will allow for a cause and effect conclusion if the difference between the two groups is statistically significant. So again, that random assignment, you're randomly putting one here, one here, one here, one here, one here, one here. So you're going to have approximately the same size groups, and ideally they're going to be at about the same ability level. All right. Next up, here are some box plots. They want you to compare distributions. Whenever you're comparing distributions, you want to think of SOCS, all right, with context. So we're going to address the shape first. Shape, the distribution of the number of barbell curves, there's my context, is slightly skewed right for both groups. Right, if I check it out, here's our median. We've got a little bit more going on the right-hand side for both of these. With more skew in the distribution for those that were not encouraged, right? Not encouraged seems to have a little bit more of a skew when you're comparing those two sides. All right, so then outliers, none. We don't see anything going on. Center, that's going to be your median. The median is greater for the encouraged group, right? If I look at my axis here, it's about 31 to 19. My spread, the interquartile range is greater. If I look at it, just by looking, it's greater for the encouraged group. I went ahead and did some calculations because you never know if they want the numbers or not, so it's always a good idea to do it. 50 minus 11 gives me a range of 39. 35 minus 9 gives me an interquartile range of 26. So the middle 50% of my data has a spread of 39 and 26. All right, so there we go. We've compared it with context. Next, state the hypotheses Daniel should use to test his belief about receiving encouragement during exercise. So remember, I circled that at the beginning. What was his belief? He believed that if you're encouraged, right, come on, you can do it, you're going to do better on average. All right. Okay, so make sure you define any parameters you use. Got it. So I'm going to use E to represent the encouraged group, and I'm going to use N to represent not encouraged. You can use any subscripts you want. So the first group is the true mean number of barbell curves completed in the encouraged group, and is true mean number of barbell curves completed in the not encouraged group. So this is just following that first step when we grab those magnifying glasses for tests, right, where we're defining what it is we're investigating. So the null hypothesis would be, there's nothing to see here. There's no difference between the groups. However, Daniel thinks that if you receive encouragement, you're going to perform better. So we're looking for evidence, right? The alternative hypothesis, we're looking for evidence that we do better. This is higher when we're encouraged, right? Greater than 0 when we subtract it. On to part D, dog. Identify the significance test Daniel should use to analyze the results of his experiment and show the conditions for this test are met. Perfect. Well, we've got two samples, right? We had two box plots. We had two groups going on. So two sample t-test would be best. Conditions, random. Treatments were randomly assigned. Normal. Neither distribution shows strong skewness or outlier. We didn't have the central limit theorem here. Central limit theorem would say you have 30 in each group, and that is not what we have. They probably did that on purpose right? We have 29. So we're almost there, but not quite. So no central limit theorem here. Neither distribution shows strong skewness or outlier. T distribution is robust. It is okay to proceed. And this is looking at the box plots. All right, the box plots were what helped me draw that conclusion. Notice I didn't mention anything about independent. It was not required for this problem. So you might have seen in all these reviews that independent is kind of forgotten in all of this. I always say don't forget about it, but let's, I suppose, focus on random and normal for your AP exam because that seems to be the most important stuff. Okay, so on to E. The p-value for Daniel's test is 0.107. Oh, okay, that's not real low. What conclusion should Daniel make at the alpha level 0.5? Got it. So the p-value, you always compare it to alpha. Is it smaller? The saying is, if the p is low, reject the ho. Our p-value is not quite low enough, so we don't have the evidence. We fail to reject. We have insufficient evidence at alpha equals 0.05 to conclude that people perform better, i.e. more dumbbell curls, when encouraged. Notice my conclusion is in terms of the alternative hypothesis, right? We're looking for evidence of this, and we did not, right? We did not have the evidence at that alpha level. So those are that's your go-to sentence. I don't have how you would score this because this is not a previously released problem, but you could probably estimate it, look at it. Are you partially there or are you all the way there? All right.